Hello. Hiya. So hopefully you can see the screen. Um, there we go. It's live. So the idea for tonight's stream is basically to do any question, any paper that you want me to go through and explain. Obviously I'll have no prep time. I haven't looked at these questions before. I've done quite a lot of papers, as you would expect, being a maths teacher, having a YouTube channel. So yeah, feel free, put in the chat any question on any paper you want me to go through. The other options that I've got are I can go through a higher paper, which may be the most useful for the students at my school with the mock exam tomorrow, or I can go through an OCR paper. I've got a further maths paper, I've got a foundation paper. So whichever one you would like me to go through, let me know. I'm just trying to see if the stream's working. I hope it is. There's people that are joining, so I think it is still working. I have got some McDonald's at the side, so if you see me eating some chicken nuggets, that's my dinner. It's because I haven't eaten yet. I don't want it to go cold, but yeah. Right, so, like I say, put in the chat. I don't know how to do a poll. I wish I did, because that could be quite useful. But, let me see if I can work it out. Higher paper, right, okay. That's fine. Let's see if I can work out how to do it. I got a poll here. Right, let me sort this out. This is a new thing for me. Right of paper would you like me to go through? And then, like I say, I've got edit cell higher, which is on the screen now. Edit cell orientation. I've got OCR higher. I've got AQA further maths. Right. Start poll. I think I know what the results of that's going to be, but hopefully putting a poll in will mean you don't have to actually type in the chat, which I know some people might not want to do. I was wondering, while people are doing that, and got new branding on the McDonald's bags, which is a Grinch theme, isn't it? So I didn't realise till today. They've got the cheese melt share box back, which I really recommend the cheese melts. Really good. But you didn't think you'd be tuning into this, did you? Right. I'm going to do about half an hour. I'll give it a couple of minutes and then I will just make a start on this paper if the votes don't change. Right. I think it's pretty unanimous anyway. Right. I'll try and eat quietly because that's not a nice thing to hear. Okay, right. Let's start going through this then. Now, what I would say is the start of the higher paper overlaps with the end of the foundation paper, so it should be useful for both. And I can see the chat, so if you put anything there, I should be able to see that. Right, so let's make a start. Okay, so we've got 8 numbers written in order of size, although some of them are letters. H, J, and K are integers. The median of 8 numbers is 10, so that means we add them all together, divide by 8, and we get 10. So that will tell us what the total is. We can do that in a second. The mode, which means the most common number, is 18. So that means these two K's down here have to be 18. Mode means most common, comes up the most. The range, so biggest takes smallest, is 13. Right, I've ordered too much food. That is what I normally do. So, 20 chicken nuggets and the cheese milk share box, but they never have the chocolate milkshake, so I couldn't get one of them. Right, these numbers here have to be 18. Mode comes up the most. Range is biggest takes smallest, so if we do 18, take 13, we're going to get 5. Okay, so this has to be a 5, H. And then we know the median, sorry, I said the mean. Median, that's the number in the middle, is 10. So we've got 1, 2, 1, 2, 1, 2, 1, 2. So I cross those off to make it a little bit easier. 1, 2, 1, 2, and then I've got two numbers in the middle. And what this means is actually in the middle of those two numbers, the average or the middle of those two numbers is going to be 10. So this is 10, which means either side is going to be the same difference. So that's 2 down, this is going to be 2 up, this is going to be 12. Okay, so H is 5, J is 12, and K is 18. J is 12, K is 18. Okay, right. Moving on to the next question. Trying to source everything out, too much food on the desk. Right, on the grid, draw straight lines with this equation. Y equals 2 is going to go through the y-axis at 2. So that's just going to be a straight line, like I say, going through the y-axis, which is the vertical one, at 2. Okay, use a pencil and a ruler. There we go, that'll do. X equals 6 goes through the x-axis at 6. So again, that is going to be a straight line like this. Okay, and then y equals x plus 1. Now, sort of gradient of 1, which means that for every unit we go to the right one, we're going to go up 1. Okay, and then goes through the y-axis at 1. So it's going to start here. I'll do the line. It's going to start at 1 on the y-axis, and then it's going to go up by 1 each time. Now, the other way you could do this is you could put that last equation into the table function on your calculator, and you could put in, that'll do. You could put in 0 through to 8 and see what you get. Plot your coordinates, straight line through it. Okay, table function works slightly different on slightly different calculators. Okay, so on the new one, you need to define the function first, then you go into your table function, and then you can input your values. On the old one, what you need to do is you go into table function, you define, so you write in what f of x is there. F of x just replaces the y, so you type in 1x plus 1, and then you go onto your table, you have to set your start and your end, and your step, and the step's where it goes up by. So the start for this one will be 0, end will be 8, goes up. So step 1, press equals, and it will give you the table. Right, the next bit, part B, we've got to shade these regions. Show by shading the region that satisfies all three of the inequalities. Sorry. So y is greater than 2. What I'm going to do is I'm going to label the lines I've drawn. So y equals 2 is this one. X equals 6 is this one. That's going to make it a bit easier to see what we're doing in a second. And y equals x plus 1 is this one. To do y is greater than or equal to 2, we need to be above this line. Now, use arrows, because then we can see which section works for all of them, and then we can shade it in. X is less than or equal to 6. So that is going to be all the numbers that are less than 6 on our x-axis, so that's going to be this way. Okay, and you can kind of work out at this point where it's going to be. It's probably going to be this bit, this triangle. Now, y is less than or equal to x plus 1. With this one, y is your height. And if we want y to be less than or equal to, we want to do below. And you need to do your arrows for this vertically. So they either go straight up or straight down, okay? We want y to be less than or equal to, so we do straight down, okay, because we want the height, which is y, to be less than. Now, just a note on this, we don't need to change our lines here or rub anything out, because this has got the equal to bit underneath, okay, all of them do. Now, when you're drawing the inequalities, if it's got the equal to part included, it's a solid line. If they use more ink drawing the inequality, you use more ink drawing your line, so you do a solid line. If they don't have the equal to underneath, you need to do a dashed line. Yeah, I can have a look at some end questions as well. Yeah, I can do that. So I'll try and do a split rather than doing all at the start. What I might do in a second after this question is I'll look at, I'll try and pick out some questions, okay? Right. So then what we need to do is we need to shade that triangle. And we need to label it R as well, so probably should have done that first, actually. I mean, I could have done an arrow to it as well. But yeah, there we go. You could shade it in as well if you want to. It's a bit confusing. It says show by shading on the grid, and then label the region R. How are you supposed to shade it and label it R? Unless they mean shade these other bits. Not particularly clear, but that's fine. Okay. So, what I'm going to do next is have a quick look through the rest of these questions, and maybe I can do a quick explanation for some of them. So, plane takes 9 hours, 36 minutes to fly from New Delhi to Perth. Plane flies at an average speed of this. So, speed equals distance over time. We need to change this into just hours. So, divide 36 by 60. Okay, and then add that on to 9. That's your total amount of hours, because we have to work in the same units. Work out total distance. Well, speed is distance over time. Or if you use this triangle, your distance is speed times time. So you do 820 times by 9 and 36 over 60. So do your 36 over 60, add it on to 9 and then times that by 820. This show that one. Keep the right-hand side the same. So always keep that being 8, and then just change your left-hand side, okay? So 2 times 7 is 14, add the 4 is 18 over 7. 3 times 9 is 27, add the 1 is 28 over 9. 18 times by 28, 7 times by 9. So 504 over 7 times 9, which is 63. Okay, that's equal to 8. And then what we can do there is, I probably want to explain somehow here what I'm doing, because I want to basically, because of the show that one, this is a bit, normally you end up with a fraction, so you can just simplify it into a fraction. The other thing you might want to show here, just to be a little bit careful and make sure we're getting all 3 marks, is to write it actually like this. So 18 times 28. 7 times 9. You've just got to be careful with these types of questions and make sure you hit what they want on the mark scheme. So putting in more detail, well, this is better, and keep that right-hand side the same all the way down. So what do we get? 504 over 63 equals 8. And then what I'm going to do, I'm just going to divide top and bottom by, well, 63. But then it's just going to simplify, isn't it? So you're just going to get 8. So, yeah, I mean, what else can I do here? Normally there's a little bit more to write here, but because that goes in exactly 8 times, it's there's not a lot more we can actually write, to be honest. What could we do? We could do it this way. So I could write this, and then I could do like that. Not divide by 8, divide by 63. Okay, that makes it clear what I've done. Okay, there we go. That should be sufficient. You'll pretty much get your marks for this bit, your marks for this bit, marks for that bit, basically. So, yeah, pretty straightforward. Next one, work out the value of x. So that's trigonometry. Opposite and hypotenuse. That's opposite the right angles. That's your hypotenuse. Don't need the adjacent, so you can cross that out. So that is going to be sine. Okay, so sine 34 is equal to the opposite x over 6.5, then times by both sides by 6.5. You could also use this triangle if you want, and then you don't have to worry about rearranging. Opposite, cross that out. Sine, because it's next to hypotenuse, is going to be sine times hypotenuse. So yeah, sine 34 times 6.5. And that gives you the value of x, not 3, gives you the value of x. Okay, which is 3.63. Histograms. Okay, yes, well, I'm looking at histograms. Right. I'm going to go through, and feel free. Yes, this is a higher paper. Might not seem like it at the start. They start off fairly easy, and then they get harder as you go through. I'm just going to have another one of these cheese melts quickly before they all go cold. I'm going to go and do some end papers, end questions now. And then I'll have a look at some histograms as well. Let's see how many questions we've got here. This looks like a nice one. This one might be worth looking at as well. Oh, this looks interesting. Vectors I'm not going to do because, well, the students at my school at least, which is probably going to be most people watching this, don't need to do vectors. Or which one's this? Transformations. Going to leave that one. And then I put the paper on again by accident. Right. Let's go back. That looks interesting as well. Right, let's go from 18, I think. We'll try and speed run this a little bit as well so we can get through as much as we can. Right. Finish the cheese melts onto the chicken nuggets. I'm not going to eat them all now, obviously. Right. Straight line P has equation 5y plus 2x equals 7. Find the gradient of a straight line that's perpendicular to P. So we need to get the gradient first of all of this line, and we need to get the gradient by having y equals. So take 2x from both sides. 5y is equal to minus 2x plus 7. Divide both sides by 5. And you've got to divide everything by 5 here. And we're going to get y is equal to minus 2 over 5 x plus 7 over 5. Now that's the gradient here, minus 2/5. We need to find the gradient of a straight line that is perpendicular. So negative reciprocal, you flip it, and if it's negative, goes positive. If it's positive, goes negative. So this would be 5 over 2. Okay. Right. I am just going to get up the mark scheme just so I can double check and make sure I'm not telling you anything that isn't right. You know, I don't want to get to the end and the answer not be right and then you go away thinking that's how you do it. If I make a careless mistake with one number, let's say, that is possible. NXL ideas yes, you would get a mark just for finding that gradient. This is 2 marks, so I would expect 1 for rearranging the equation, and sometimes it might be for a correct first step, but for this one, it would probably be for getting this equation at the bottom here, and then the other one would be for getting that gradient there. Right. Okay, next question we're going to have a look at is this one, which is a bounds one. And I've done a bounds question before, but this one is a little bit different, where we're going to have to think carefully about which bounds we're using. Right, 1 second. Just scrolling down. What question are we on? 19. That's fine. Okay. So, G equals C over 2F minus 3H. C is correct to the nearest whole number. F is correct to 2 decimal places. H is correct to 1 decimal place. We need to work out the lower bound for the value of G. You're going to do a number line for C and for F and for H. Cosine rule, yep. We'll have a look at that as well. So, nearest whole number, let's go down 1 whole number to 7, 1 up to 9, halfway in between, 7.5, 8.5. So we've got our bounds there for that one. Let's do the same with F. So that is 6.62, and that's correct to 2 decimal places. So go down by the second decimal place to 6.61. Up to 6.63. Halfway in between is 6.615. Halfway in between 6.625. And the last one is H. We've got 1.2. So 1 decimal place up is 1.3. 1 down is 1.1. Halfway in between is 1.15. Halfway in between 1.25. Right. What we need to do now is work out, we want the lower bound for G, And the trickiest bit here probably is working out, well, if we want the lower bound, do we want the lowest thing divided by the biggest thing, or the biggest thing divided by the lowest thing? So let's think, if we had, let's say, 8/2, more of those 2's would go in than if we had something like, if we had a smaller number like 6/3. Yeah, so if we had a bigger number on the top and a smaller number on the bottom, we get a bigger answer. Okay, that would be bigger, that would be 4. If we have a smaller number on the top and a bigger number on the bottom, we get a smaller answer. So what that means is, on the top, we want the lower bound, because we want the lower bound as our answer, over upper bound. What that means is that we need to make the bottom. Is this definitely on the test? I don't know, because I haven't seen any of the tests, so I have no idea. Can't tell you. And it wouldn't be right for me to tell you, even if I knew if it was. So, but all of this stuff will help. And even if it doesn't help tomorrow on the test, it will help in the long run on the test as well. We need to get back to this. We need to get the upper bound on the bottom. So we need to make sure what the biggest thing on the bottom. Now we need to then consider this. So 2f minus 3h. So again, do we need the bigger thing take away smaller, or smaller thing take away a bigger thing? Now, again, you could try this with numbers to check for yourself, but actually what we need is the bigger thing take away smaller. So on the bottom here, if we want the upper bound on the bottom, we need upper bound take away lower bound. Okay, take away smaller thing from a bigger one, you're going to get a bigger answer than if you do it the other way around. So what that means is we need the lower bound of C over 2 times upper bound of, what letter is it, F, minus, and you don't have to write all this out, I'm just trying to explain it as best I can, minus, what are we doing, 3 times the lower bound of H. Right, then we can put our numbers into this. So lower bound of C, well, C was this one, this is C, this is F, this is H. Lower bound of C is 7.5 over 2 times upper bound of F, 6.625, minus 3 times lower bound of H, which is 1.15. Okay, and that should give us our answer. Put that in the calculator. 2.2 times 6.625 minus 3 times 1.15 gives us 0. So we need it to 3 decimal places. 0.765 is our answer. Okay, right. I'm going to move on to another question. I see where someone's put a question in the chat, so I will have a look at that in a second. Although they haven't put the full question in, they put the coordinates. So if you could put the full question in, that would be helpful. It says the coordinates of R, and then it's stopped. So I'm not going to be able to answer it unless you put the full question in there, or put the paper it's on and the question number, and I will explain it. It'll be easier to see if I definitely got the question in front of me, the full question. Right, moving on. Let's do this one. Question 5, paper 2, 2024. Right. Okay, yes, I will have a look at that in a second. What I'm going to do is I will do... If anyone wants me to do any of these questions specifically, some people said some of them at the end of the paper, then let me know. So like 20, if you want me to do 21, which I like the look of, because if you watch my channel, you know I like geometry problems. If you want me to go through 22, which is an intersecting curve and line problem, but actually it's a quadratic simultaneous equations problem. This is an indices problem, which again, I quite like the look of that one, but do question 20. Okay, let's have a look at that one then. Right, question 20. Given that k was this and x equals this, express 5k over x plus 2 in this format. So what we're going to do is I need to start off with 5k over x plus 2, substitute in for k, so I'm going to get 5 lots of x minus y over x plus 2. I'm going to now substitute in for x, and I'm going to get 5 lots of 1 over 4y minus y, all divided by 1 over 4y plus 2. Expand the bracket, I'm going to get 5 over 4y minus y over, minus 5y, excuse me. Minus, because you've got 5 times this and 5 times this, minus 5y over 1 over 4y, let's scroll down, plus 2. Okay, from there, I need to get rid of these fractions in fractions. So I'm going to times top and bottom by 4y, okay? If I do the same top and bottom, I'm not going to change the value of the fraction. So 5 over 4y times 4y is 5, minus 5 times 4 is 20, y times y is y squared, all divided by 1 over 4y times 4y is 1, plus 2 times 4y is 8y. Now we then need to look at where we need to end up at, and actually, we've already got it. 5 minus 20y squared, 1 plus 8y. That's the format that we needed it in. So that's that one done. The bit that people would struggle with here probably is knowing what to do about the fraction inside of another fraction. And just times by the denominator, top and bottom, and that'll cancel it out. Okay. Right. Question 5, paper 2, 2024. I think, if I scroll right up, I think there's a histogram question on here, which is good. Is it this one? Question 5, paper 2, 2024. I think it's this one. I think I've done it. So maybe you joined and you hadn't seen me do it, or maybe you want me to explain it again, I don't know. Let me know in the chat. Okay. Hi, Bird Flash. Let me know if that's the right one, or if it's a different paper. It might be the November paper. Okay. Right, I'm going to look. There was a histogram question and a cosine one people wanted me to go through. So histograms... cosine rule, I think that's it. Right, let's go down. I think there's one on here. And the other thing I'd recommend, here we go, that's cumulative frequency, is Maths Genie 21. Okay, I'll have a look at that in a second. Maths Genie and using their resources, because they've got videos and they've got answers on there. That's really good. Is there a histogram one on this one? Venn diagram? I don't know if there is. Right. Let me do 21 then, and I'll come back to the histograms. Right, I like the look of this one, but it doesn't mean necessarily it's an easy problem. Sides of the square are tangent to the circle. That means they touch the circle. That means the diameter of this circle is going to be the width of the square. Okay, the total area of the shaded region is 80 centimeters squared. So these bits here, added together, is 80 centimeters squared. Work out the length of AC. That's the diagonal. Okay. Right, so what we're going to do is I'm going to call this, we can call it the radius X, or we can call it R. Let's call it R, just for consistency. It's the radius. Okay, so what we can do then is the width of my square is 2R, and the area of the square is going to be 2R times 2R, which is 4R squared. Now the area of the circle is going to be pi r squared, because the radius is just r, and the formula for area of the circle is pi r squared. Now the shaded area equals the area of the square, so 4r squared, minus area of the circle, which is pi r squared. Now that's going to be equal to 80. Now what I'm going to do is I'm going to factorize the r squared out of this. Kirk said, whoa. I'm not sure what that's about, Kirk, but hopefully it's a good thing. Right. 4 minus pi, because I factorized the r squared out, and that's equal to 80. I'm going to divide both sides by 4 minus pi. And I can just do that on the calculator, and that will give me a value for r squared. So 80 divided by brackets 4 minus pi, that gives me 93.195 ... Keep that answer on your calculator, or write, 6 or 7 decimal places down. I'd say make sure you've got enough down so you're not going to get a rounding error. Square root both sides of that, and we're going to get r is equal to 9.653799632 ... Okay, that'll be fine. There's enough decimal places. Right, so that's our radius. Now that radius means we can now put on the side length of the square. So side length of the square would be 2 times that. So 2r is that times 2. Excellent. Yes. Lots of 6s and 7s. Thank you, Kirk. 19.30759926 ... That is the width of our square here. So that's the 19.307. I'll do ... Oh, nearly lots of chicken nuggets on the floor. And that's also going to be this height up here. So 19.307 ... Keep that answer on your calculator. Now what we want to work out is A to C, which is the diagonal of your square. And so to do that, we need to use Pythagoras. Okay, there we go. So we're going to do the bottom squared, 19.307 squared, plus 19.307 squared, add them together, square root. Okay, so square root 19.307 ... squared, plus 19.307 ... squared, and square rooted. Okay. I'll have a look at some further maths in a second. So square root answer squared plus answer squared gives me 27.3, and that would be centimeters. This is a tricky question, so if it is confusing, this is one of the questions at the end of the paper. Pretty much about halfway through, they do get quite difficult. Now, what I would say about that is actually the percentages that are needed to get like a grade 9. Last year, I believe, was 86%. But in the last 7 years, the average is about 75%. And that's obviously the highest grade. So you don't need to be getting every single thing right. So you could see this question and get a few of the first bits right, like area of the circle is pi r squared. Okay, you could get area of the square is 4r squared. You can make an equation, put it equal to 80. You're getting a few marks there. Okay. So, yes. You don't have to get everything right, and the questions at the end of the paper are difficult, so do be aware of that. Right, that's question 21. Let me see. So I've had a few requests earlier on to do cosine rule and to do histograms. So let me do some of those first. I will just quickly need to find some of those questions because I didn't have those set up already. So just give me a moment. Right. What I will do is I am just going to use probably the sheet from Maths Genie, I think. So I don't think I've got anything with all the questions on myself, past paper questions from or on histograms. Not that I could find quickly anyway, so I will just use this very quickly. Histograms, right. And then let me put that into this. I'm going to make a new page. Right, let's print that. While that's doing that, I'll hit chicken nugget. It's on cold now, don't taste the best, I'm going to be honest. Right, histograms. Let's do this. So, sorry, trying to chew as rapidly as I can. The key thing with histograms is that frequency density is the frequency divided by the class width. And the class width is how far apart these numbers are. So 20 to 30 would be a class width of 10. So I'll quickly do a drawing one for you first of all, and then we'll look at a problem solving one as well. So here, and what I'm going to do is I'm going to write on the class width. So that is a class width of 10, 35 to 30 is 5, 40 to 35 is 5, 50 to 40 is 10, 65 to 50 is 15. Now, let's do frequency density over here. Now, frequency density is, like I say, your frequency divided by your class width. You need to remember that. Okay, so what we need to do is 20 divided by 10. Okay, so 20 divided by 10 is 2. 22 divided by 5, I'm going to use a calculator for, which is 4.4. 16 divided by 5 is 3.2. 13 divided by 10 is 1.3. 9 divided by 15 is 0.6. And then what we're going to do is we're going to need to plot this. Now, on my grid down here, there's nothing labelled at the moment, so I need to count the squares. Normally on an exam paper, these things will be already labelled. Where did I get the chicken nuggets? McDonald's. Isn't that in the formula sheet? I don't believe so. I would just double check for you now. I've got to be honest, a lot of the stuff in the formula sheet I've just memorised because I've done it so often. I don't think it is. No. So you do need to know that for the histograms. Inequalities question. I did do one earlier, but I can have another look at one as well. Yes. Right, back to this. I know I need to go from 20 up to 65, and I want to have it, evenly spread out. So 20, 30, 40, 50, 65, that would work. So I started at 20 and did 30, 40, 50, 60, 70. So that is my age. And then I need frequency density will always go on the left-hand side, okay? So from there, what I'm going to do is I need to do a height of 2, and I need to go from 20 to 30. So I'm going to do this, try and do this with some straight lines. So 20 to 30. Oh, I haven't labelled my y-axis yet, so let's do that first, actually. Let me just get rid of that straight line. Now, I know we need to go up to a height of at least 4.4. So 1, 2, 3, 4. 1 here, 0 here, 2, 3, 4, 5. Okay, so let's do the height up to 2 on the first one, and that's 20 to 30. So I'm just going to go across from here. Going to go down like that. And then we're going to go 30 to 35, it goes up to 4.4. So on 35, going up to 4.4. Each little square is 1 on my scale, so that makes it pretty easy. Go across. And I'm just going to extend this line I did before, if I can. Here you go. The next one, 35 to 40 is 3.2. So again, we'll do that one. So this is going up to a height of 3.2. Make sure you use a pencil and a ruler when you're doing this. You don't want to make, well, if you do make a mistake, you want to be able to correct it. Okay, on exam paper, you don't want to have to scribble anything out. Next one, 1.3, and that's from 40 to 50. 1.3. Okay, go across. Okay, and then I need to do 0.6 from 50 to 65. 65 is there up to 0.6. And then we need to go across. Now, the other thing to tell you about histograms is the area of each bar is your frequency. So if I did 10 times by 2, that is 20, which is what my frequency is, okay? 5 times by 4.4 is 22, okay? And then the next one would be 5 times by 3.2, which is 16. I'd write your frequencies inside because they are your areas. And 10 times 1.3 is 13. 15 times by 0.6, what would that be? 10 is 6, and half of that is 3, so that would be 9. Okay, there you go. Will you lose marks if you mess up and go over it? Potentially, because it may be difficult to see what your answer is. So use a pencil. Yeah, definitely use a pencil. If you messed up, can you ask for a new graph paper to redo it? Maybe. But use a pencil just to be safe. Right. I did say I was going to try and do another one of these. Let me see if there's another one down here I could do a little bit quicker. Quite often with histograms, I've got some bits missing, so you might have to complete your histogram and then use your histogram to complete your table. Now you have to use one of the bars. So here, 13 to 14, or no, sorry, it's not that one. 16 to 20 is this one. You're going to have to match those up to then work out the height, to then work out your scale, to fill in this, and to do all the rest of it. Right. Let's do this one. This is a good histograms question to have a look at. Oh. And definitely harder to eat when they're cold. Chicken nuggets. Anyway, right. Algebraic proof. Yeah, we can have a look at that as well. Proportion of plants over 25 centimeters tall. Okay. Now, we don't have the frequency density here, and there's actually no way to work it out. But all this is asking for is a proportion. And so because it's a proportion, it's a fraction, it doesn't actually matter what we make the scale as long as it's consistent. So just for ease, I'm going to make that 1, I'm going to make this 2, I'm going to make that 3, that 4, and then that 5. And then what I'm going to do, I'm going to work out the frequency. So I'm going to do 10 here, the bottom of this bar, times 1.2. That will be 12. 10 to 15, so that's 5 times by 3.2. That's 16. 5, so 15 to 20 is a width of 5 times 4.4. 5 times 4.4 is 22. This is very similar to the one we did earlier, to be honest. 10 times by 1.2 is 12. Okay, width of 10 at the bottom up to 1.2. And this one, 30 to 50 is 20 times 0.3. So that'd be 6. Now, the key bit here is over 25 centimeters tall. Now, 25 centimeters is here. And so what we're going to have to do is we're actually going to have to split this up into 2 parts, like this. So 5 times 1.2 is going to be 6, and this would be 6. Where am I getting the numbers from? So what I'm doing is I'm doing the width here. So that goes from 0 to 10. So that is a width of 10 along the bottom. And the height goes up to 1.2. So to get this one, I did 10 times 1.2. To get this one, I did 5 because it goes to 15 from 10. So that's a width of 5 times by 3.2. Next one, I did 5 because it's a width of 5 along the bottom times by 4.4. And so on and so on. So this one is 5 times by 1.2. Okay, and then this one would be, the width is 20 times 0.3. Okay, hopefully that makes sense. Now, the proportion over 25 centimeters tall, so you've got 6 adds 6 is 12. Okay, because it's this one and this one, which is over 25 centimeters tall, and it's out of the total. So we've got to add all those numbers together. So 12 add 16. Let me write this slightly different way. Scroll down as well so you can see. So 6 add 6, that's the number over 25. 12, add 16, add 22. Kirk, I'm going to mute you in a second if we keep just talking about unrelated things in the chat. Okay. Because what it does, it clogs up the chat. I can't actually then see what people are, or I don't want to miss what people are typing in. Also, I don't really want to hear about lasagna. Nothing against it. It's just, I'm not too bothered about lasagna at the moment. Right. So 12 add 16, add 22, add 6, add 6, add 6. So that gives me 3 over 17. Now, an estimate for the proportion, just double check that. So 6 add 6, and then we've got 12 add 16, add 22, add 6, add 6, add 6. So that should be the right answer, 3 over 17. Okay, and the reason that is an estimate is because we have assumed that the frequencies are split evenly, okay, in each class interval. So we have assumed that the frequency is split evenly within the class intervals. Okay, and what we mean by that is actually that there's 6 either side of this 25 from 20 to 30. Okay, factorizing. Okay, we've got quite a few requests. I will do as much as I possibly can. Quite a few requests for circle theorem, so let's go through that. Again, just give me a second. I've got something which is quite useful. Circle theorems, although I don't know if I can find it quickly, not on here. Right, so I'm going to use, what I'll do is I'll use the Math Genie stuff again. Actually, let me see if I find a circle. No, I'm going to use the Math Genie stuff, just for ease. But I have got, oh, there's Alexa. I have gone through, so if you're someone at my school, I have got all the circle theorems questions from, not including last year, but before that, probably about the last 6 or 7 years, and I've put them in order of difficulty, so where they come up on the paper. So that might be something that you might find interesting or find helpful. If you do, let me know and I can send that to you. Right, let's sort this out. Okay. Looks like a cold chicken nugget. Right. So, circle theorems, you need to know what they are, and for that, you just need to learn them. I would suggest putting them on flashcards, particularly because as well, you need to know the reasons. So you see, quite often they say you must show all your work in, or you must put down reasons. Here, give a reason for your answer, okay? Now, these ones at the start are fairly standard, fairly straightforward. So what I'm going to do is I'm going to go to a bit further down and try and find some trickier ones. So I've seen one like this, exactly like this today on a test, a past exam paper. Now, I'll go through it quickly. It's slightly different because on the exam paper, they told you this angle and you had to work out this one, okay? But what we can do with this, basically this is working the other way around, essentially. We've got points of the circumference of a circle. A, B, and BC are tangent. BC are tangents. That means my radius meets the tangent at 90 degrees, so I can put that on. Now I'm trying to work out the angle of OAC. So O to A to C. So it's this one here. Okay. Now, because these have both got right angles in here, in each corner, what I can do is I can work out this angle by doing 360, because we've got a quadrilateral here. Okay, if I can highlight it. That's a quadrilateral. Okay, far too big a highlighter, but hopefully you get the points. And so what I can do is 360, take 46, take 90 for my right angle, take 90 for my right angle, because there's 360 degrees in a quadrilateral. So that's 134. So this one here is 134. And then I've then got an isosceles triangle here, because these two sides are radii, and I'm going to try and get rid of some of the other drawings on here. Okay, and do you know what? I'm going to zoom this in a bit more so it's a bit easier to see. It's one of the good things about being on a computer. So this is 134. These two sides are the same length because they are radii. They have to be the same length, which means this triangle is isosceles, which means these two angles here have to be the same. So if we do 180, take away 134, and then split that in half, we will get those two angles and the one that we need. So we get 46. 46 divided by 2 is 23. So that's 23. That's 23. I'm just going to check which angle we needed. So we wanted OAC. So OAC, which is this one, which we've got. So it's 23. Okay. Right. I'm just going to go back up. Right. Sorry, I'm laughing because I've just seen someone in the chat who I suspect has probably just made a YouTube account. I've got a name very similar to my one. It's quite funny. Right, I'm going to go back up and do some of the more straightforward ones, just because someone's asked about that in the chat, so I'm going to go through those. This one uses the same thing. Yes, I can go through IGCSE further maths exams as well. Edexcel, I haven't done before, but I imagine it's very similar to the other exam boards. So yeah, I can do that as well. I might not be able to do that today, but I can do that at another time. Yes. Right, now, radius meets a tangent at 90 degrees. So that's 90. BAO, bow buns, just thinking of food like I normally do. This angle will be 180 minus 72 minus 90. Okay, so take those away and we get 18 degrees. Okay. Do you have to write a paragraph for the theorems used for circle questions? You have to write a reason down for everything you do. Now, that might look like a paragraph, but I would do it as bullet points. That way you can keep track of what you've done, what you've said, and what you've justified. So no, I wouldn't write, continuous prose like you would an essay. But you do need to write bullet points. I'll see if I can find an example like that in a second where I can show you. Right, BAC. So this angle, the angle at the circumference is half the angle at the center. Now, I'm going to be honest, I never really remember which way round this is, but it's always quite obvious because one is smaller than the other. So that is going to be 33. The angle at the circumference is half the angle at the center. How many questions are there on a test? There's about anywhere from about 23. I saw one today, I think with 27 on it, which is a lot. Normally about 23, 24. Does it have to be the exact wording on the sheet? No, you could say something like the angle of circumference is, or the angle of the center is double the angle of the circumference. Doesn't have to be the exact wording, though. How many marks do I need for a 4? Off the top of my head, Carter, I don't know. I'd have to have a look. It depends. It depends. I'd have to have a look. I'd suggest if you type in on Google, you can probably find it. We'll do a cosine in a second because I know someone else has asked about that. You can easily find it. So if you type in Edexcel IGCSE maths grade boundaries, then they will come up. Do you need a compass for tomorrow? You may do. Make sure you've got one, just in case. Make sure you've got all the maths equipment, compass, protractor that you should have. Take it in with you just in case. Okay. Do we need a protractor? Like I say, I don't know, definitely, but I would always bring it with you just in case. Yeah? Always bring it with you just in case. It's a maths test. Bring all your maths equipment would be what I would say. If you need tracing paper, you'll get given it, so don't worry about that. If you don't own one, you need to get one. Try and get one in the morning, if you can. Right, going to do another one of these quickly, and then I'll do some cosine rules. A few people asked about that. Now, if I draw my radii on here, again, they're tangents, so I've got 90 degrees. Work out the size of angle BOC, which is this one. This is very similar to the problem I did earlier. Angle BAC is 40. So you do 360 minus 90 minus 90 minus 40. Okay. Well, if you don't have the stuff, you need to go and try and get it. I would suggest going early in the morning and trying to get that stuff, because not only we need it for that exam, we need it for exams in the future and potentially other subjects as well, especially things like pencil cases. So yeah, definitely go and get that stuff if you haven't got it already. Right. Find the size of angle ACB. That's this one. And that would also be 51, okay? Because these are the same. 51 degrees. Okay. Now, the reason for that one would be... So I'm eating chicken nugget. Give me a second. Right. Reason for this one, sorry. Angles from the same points to the circumference are equal, or it seems worded slightly differently in other places as well. So angles in the same segment are equal, you could say as well. Okay, angles from the same chord are equal. Essentially, you've got this invisible chord here, and then both those angles are coming from this chord. Okay, they're in the same segment. You've got this minor segment here, you've got the major one on the other side there. Okay, so that's your reason for that one. Right, I am going to do a cosine rule question, because I know a few people have asked about that, so I'll do one of those. Let me see if there's one on the paper, because quite often there are ones on these papers. I'll have to be quite quick because I've been looking. It'll probably be towards the bottom somewhere. That's a ratio problem. We've got percentage one there. Simultaneous equations, quadratics, mean. So that'll be like reverse mean. Fairly common. Cumulative frequency. We've got expanding, brackets, algebraic fractions, changing the subject, quadratic inequalities, Venn diagrams. I forgot what I'm looking for at this point. Cosine rule. None of that. None of this. Maybe there isn't one on this paper. That's unusual. Normally there is at least one question on cosine or sine rule. Right, there isn't. Okay, give me a second. Let me find a question. So again, I'm just going to use a Maths Genie question just because they're really good generally for practice. So let me use this. Rinse that to where I need it to go. Right, got it. Just get everything back on the page. Okay, zoom in. And scroll down. Okay, so cosine rule, there's a couple of things we need to know about. So we need to know what the rule is, and that's on the formula sheet. So that is a squared equals b squared plus c squared minus 2bc cos a. Okay, now a is the angle. Opposite the angle is lowercase a, and your b and c don't matter. So to solve this one, we just need to substitute the values in and then square root our answer to get a rather than a squared. I'm going to try and find quickly a trickier one. This is one to find the angle with, actually. Let me show you this one. Hopefully you can see this all right. I know it's not coming up quite as clearly as I wanted it to, because the line's right, that's maybe a bit better. Now, I'm going to write down now the rearranged format. You could plug the numbers in yourself and then rearrange it, or you could just learn this rearranged format. So this is the original. B squared plus c squared minus 2bc cos a. If I rearrange this, I am going to get cos minus 1. So a is equal to cos minus 1 of b squared plus c squared minus a squared over 2bc. So this is the formula for working out an angle. So if I've learned this, I can then substitute my numbers in. This would be a, it's opposite the angle, and then b and c don't matter. Plug those into this, and then I will get the answer for the angle, and then I just need to put it in 3 significant figures. Now that's not really problem solving one, it's just knowing that formula or rearranging for that formula. Let's have a look at another one. That's one working out an angle again. This one, again, working out an angle, not too hard. This is getting more onto problem solving, because what you're going to do here is use cosine to work this out, and then you're going to use trigonometry with this side and this side to work out your angle. Okay, let's see if we can find an interesting one. This one looks quite nice, and this one will be nice as well. Okay, let's go through this algebraic one. Okay, so we've got to work out the value of x. Let me put it back up, zoom it out, scroll down a little bit so you can actually see the question. There we go. Work out the value of x. Now, this is going to be a, this can be b, this can be c. Okay, and what we're going to do is we're going to use just a normal formula. So a squared is b squared plus c squared minus 2bc cos a. Substituting into this, we've got root 73 squared equals x plus 2 squared plus 2x minus 3 squared minus 2 lots of b, which is x plus 2, times by 2x minus 3, and then cos 60. Now, this is an example of the question which would most likely come up towards the end of the paper. Do we need to know how to describe the single transformation of triangle A into triangle B? So it depends which transformations you're talking about there. If it is a transformation where it's like reflection, rotation, enlargement, translation, then yes, you do need to know how to do those. If it is like transformations where it would be like f of 2x or f of x plus 2, then I don't believe so, because I don't believe you've done that yet. But yeah, if it's like I say, if it's reflection, rotation, translation, enlargement, then yes, you would need to know how to do that. Although they don't come up very often, but they could come up. Right, so for this one, what's cos 60? That's a half. So we've got root 73 squared is 73. Scroll this down. I am going to quickly do these bits, but the way you need to do them is double brackets like this. X plus 2 times x plus 2. So to do this question, you need to be comfortable with this. I'm going to do this quickly just for speed so I can answer as many questions as possible. Because I've already been live for about an hour now. And yeah, I do want to have a little bit of a break, and you need a break as well. You don't want to be going to bed if you've got an exam tomorrow too late. Right. This is going to give me x squared plus 4x plus 4. And this one is going to give me, not equals, 4x squared minus 12x plus 9. and then minus 2 lots of, actually the minus 2 is going to be cancelled out with this, because this is a half. So I can get rid of the minus 2. We'll do a bracket though, because I need to subtract this once it's expanded. So 2x squared plus 4x minus 3x, so that's plus x, and then minus 6. Okay, so 73 equals, I've got 5x squared at the minute, minus 8x, and then plus 13, and then I'm going to minus 2x squared, I've got a minus x, and I've got a plus 6. So let's simplify that again. 73 is equal to 5x squared minus 9x plus 19. We're going to take away 73 from both sides here. So 5x squared minus 9x. 19 minus 73 is minus 54. And then what we are going to do is we need to either use something like the quadratic formula or try and factorize it, although because there's a 5 in front of the x squared, I'm just going to use quadratic formula. And so I'm going to do x is equal to minus b, so that's minus 9, plus or minus square root of minus 9 squared. This is on the formula sheet, by the way, as well, so don't worry. Minus 4 times a, which is 5, times c, which is minus 54. All divided by 2 times 5. Okay, right. So I'm going to get two answers. One when I put the plus in my calculator, one when I put the minus in. Okay, so fraction button, minus 9 plus square roots, brackets. Make sure you put the negatives in brackets before you square them. Otherwise, your calculator will do it wrong. It will square the number and then it will make the answer negative. So yes, make sure you do that. So I get 4 points, and these aren't the nicest of numbers. 307. And then the other one is minus 2.507. Now, can't have the negative because it's got to be a positive value. Let me just double check this answer because I haven't done that quite quickly. And there is a lot of algebra. I haven't done all the bits in between necessarily. So let me just check that very quickly, because what I don't want to do is give you anything which is not quite the right answer. But what do we get? Right. So I've gone slightly off here somewhere because the answer should have been 6. So let me just check my numbers. The method's right. I've just done a slight calculation error there. 5x squared minus 8x plus 13. That's all right. Minus 2x squared minus x plus 6. I see what I've done. This 5x squared minus 2x squared should have been 3x squared. There you go. It's what happens when you're rushing, which is why it's a good thing, if possible. I know it's not always possible if you're in a test, not to rush. So I need to change this minus b plus or minus square root b squared minus 4a c, and then a on the bottom. 3 there, 3 there. Now look, obviously, anyone and everybody can make mistakes, myself included. If you know how to do all the right methods, you're going to make sure that you get all, sorry, not 3, 6. You get majority of the marks, even if when you do make a little numerical error, like is always possible. Yeah, just be careful, just double check. So what I would have done if I didn't have the marks in there to check that quickly, I would have just gone back through and reread what I'd done and checked it. If you don't get a nice answer, that makes me want to check it. If I ended up with an answer of 6, I would have been like, oh, that's pretty nice, pretty confident that's right. So if you get like a decimal like I did, just double check it. But obviously that would mean this answer down here is different as well. However, it's going to be negative, which is why we can't use it. So I'll just get that answer here for us. So that would have been minus 3. Okay, you can't have a negative. So same as before, can't be that one. Okay. All right, let me see what's in the chat, what people want me to do. Okay. How many marks would this be? Good question. 5 marks, okay. Now this is also on 5 marks, I think, would probably sound right. Some of the marks on Maths Genie where the worksheets are not always accurate, but I think 5 marks for that seems reasonable. 5 or 6. Reoccurring decimal show that question. Yeah, it should have been a 3 instead of a 5. Yes, you're right. My mistake. Yeah. Okay. Reoccurring decimals. Let's have a look at those. And then I'm going to have to end shortly because I do need to have a bit of a break as well as you do. Algebraic proof, I've seen that one as well. Let's do a reoccurring decimals and an algebraic proof. Reoccurring decimals. Okay, let's put that on the page. There we go. And then let's do algebraic proof. Thing that'll just be under proof instead of algebraic proof. Okay. Written that. Right. So we've got this. Go away, close that. Super. Ratio quadratic algebraic proof. Right, that's very specific. I will see if I can find one. Okay. I'm not quite sure, if I'm totally honest, what you mean by ratio quadratic algebraic proof. If you've got a specific question, like paper, whichever paper it is, put the number in, the question number, and then I can find that for you. Let's go with, this is basically just algebra. We can do that one though. Some of those are always a square number. Let's pick a nice easy one, and then we can always do a harder one because it shouldn't take too long. Let's do number 2 here. Prove algebraically that the sum of any 3 consecutive even integers is always a multiple of 6. This is actually quite a nice one, I think. So, sum means add, consecutive means one after the other, even integers. So what I'm going to say is let n be an integer. That means a whole number. Then 2n would be even. Now the next even number has to be 2 up from that. So it would have to be 2n plus 2. The next even number up from that would be 2n plus 4. Okay, if we think 2n is 2, if we add 2 to it, we get 4. If we add 4 to 2, we get 6. Okay? Right, and we need to add those together because we're doing sum, and they're consecutive. Let's see what we get. So 2n, add 2n, add 2n is 6n. Add 2, add 4 is 6. Now, to show that something's a multiple of anything, what you need to do is factorize that number out. So we need to write it as 6 brackets n plus 1. And then I'd write a statement at the end, and I'd say, you can use 3 dots like this. That means therefore in maths terms. Therefore, and then I'd copy the question, and I'd say this bit. Therefore, the sum of any 3 consecutive even integers is always a multiple of 6. Basically, you're writing down what you've proved. Okay? And then also it means you don't have to think about actually what you're writing. Consecutive integers is always a multiple of 6. Okay. Super. Let's do another one of those. Let's find a harder one. That's okay. Okay, number 13 looks quite nice. Let's try number 13. That looks interesting. Prove the difference between the squares. So difference means we've got to subtract. squares of any two consecutive integers, okay? Two consecutive means one after the other, is equal to the sum, that means add, of these integers. So, let n be an integer. If it's not an integer, if it's not a whole number, then everything kind of breaks. If this has never been taught, then it won't be on the exam, but you should know, because there'll be a revision list on Frog or wherever, if this is on the exam. I'm only doing this because someone asked in the chat, so this might not be relevant to you specifically. It's just someone has asked about it, so that's why I'm going through it. You may not have done it yet. But yeah, check revision lists to be sure. This is called proof. Okay, so let n be an integer. Difference between the squares of any two consecutive integers. So if n's a whole number, a consecutive to the next one would be n, and then it'd be n plus 1. N plus 1 would be the next one. So the squares, and we need to do the difference actually. So I actually need to put this over here so I can subtract them. So the difference of the squares of only two consecutive integers is equal to the sum of these integers. So equal to the sum of the integers, which is n plus 1 add n. Okay, so what we get then is, if we square these, again, I'm not going to write it all out, but this is what you should get if you do all the working out. 1 times n is 2n plus 1 minus n squared, not plus n squared, minus n squared, and that's equal to 2n plus 1, and actually those will cancel, so you get 2n plus 1 is equal to 2n plus 1, and therefore, and then you write the question out again, this bit. Yeah, all of that bit, you just copy and paste. And it's annoying to write, but it saves you having to worry about what to write as well. Okay. Right. Let's do a recurring decimals to fractions question. Okay. Let's do quickly one of these, just in case someone this came up. How would you do this? So we need to do 4 divided by 11. How many 11s go into 4? 0. Decimal point, 0, carry the 4. Decimal point, same place. 11 into 40 goes 3 times, remainder 7. 11 into 70 is going to go 6 times, remainder 4. And then we've kind of got this repeating pattern. But obviously this is something you can check on your calculator. So 4 over 11 is going to be 0.3636. So we're going to get okay. I don't know what all these stickers are in the chat. So I'm gonna... Right. Quadratic parabolas. Okay. We can have a look. Right. Okay. I don't know what's going on in the chat. I'm gonna be real. Right, let's do one of these. So let x equal 0.888 reoccurring. Then we're going to do 10x. We need to basically get another multiple of that where it's got the same reoccurring part after the decimal place. So 8.88 ... We're going to do 10x minus x, which would be 8.8 reoccurring minus 0.8 reoccurring. So that is 9x. Now the reoccurring parts here are the same, so they will cancel and we will get 8. Divide by 9 on both sides. And we get x is equal to 8 over 9. Okay. Right. Can teach me differential equations. My exam is next week. I can, but I'm not going to be able to do it today, I don't think. It depends what type of differential equations as well, because there's lots of differential equations. If you just mean differentiating, at like a GCSE level, that is pretty straightforward. If you mean something like partial differentiation or there's all sorts of different things, chain rule, etc., then that's more complicated. That'll be A level, potentially, you know, even degree level stuff. Right. Let's do one of these very quickly. So let x equal 0.23. I'm going to do it with the dot above for the recurring part. Okay, 1 second. Right. Okay, so I'm going to times this by 10 first of all to get 10x equals 2.3 recurring. Now I need to get it, so I've just got my recurring part after the decimal place. Okay, what I then need to do is I then need to get another multiple of that where I've got the same recurring part in the decimal places. So I'm going to times this by 10 again to get 100x equals 23.3 recurring. Okay. Now what I can then do is subtract the 10x from the 100x, and that will cancel out the recurring part. Minus 2.3 recurring. That's going to give me 90x is equal to 23 take 2 is 21, and then I'm going to divide by 90 on both sides. And I'm going to get x is 21 over 90, which when I divide by 3, I get 7 over 30. Okay. Right. I'm just going to have a quick look if there's anything else that people wanted me to have a look at. Okay. Right. Scrolling up the chat, sorry. 1 second. Quadratic parabolas. Okay, so I guess that's sketching quadratics. Let me do... I can have a look at quadratics, but quadratic thing with a square. So that's completing the square. Is the formula for the x-coordinate of the vertex of a quadratic parabola on the formula sheet. The formula for the x-coordinate. No. I think you mean completing the square. Let me have a look. Inverse proportion. The vertex in a parabola. The way you do that, I think your name's Howard. It's got an O and a 4 in it, but I think it's Howard. Is you need to complete the square, and what you're looking for is a minimum points. Yes, Toyota is right. So parabola is like quadratic. So a parabola is basically like this. Yeah. Just a different word for a quadratic, essentially. Yeah, turning points of a parabola is the same thing. Yes. Real insert name. Okay. Right. Someone said about I'll do 5 more minutes, and then I think I will need to get off. Unfortunately. 1 second. What have I done there? There we go. Right. Bounds. Okay. Right. So final thing I'm going to do completing the square. I'm going to do bounds. And then I'll do an inverse proportion question. Let's see if I have done a bounds one earlier, actually. So actually, you know what? I'm going to leave the bounds question because you can go back earlier in the stream at some point and find that. Because I did one on this question. This paper is actually quite a complicated bounds question. Bounds question wasn't the easiest. So it was this one. Okay, where I worked out the bounds here, and I had to work out whether it was lower bound on top, upper bound on top, etc. And that's quite a complicated one, but use Mathgenie in practice and work out whether you need the upper bound on the top or lower bound on the top when you're dividing, depending on what you are looking for. Okay, so this one we wanted the answer to be the lower bound. So inverse proportion and completing the square. Let's have a look at those. Right. The last final few things. Thank you for all the people as well joining. I hope it's helpful. Yeah. Can definitely do this again if people think that it's helpful. Right, completing the square. Also, if it's helpful as well for me to do something like this, where it's, any paper, any problem, then we can definitely do this again, because I spent a long time doing it tonight, nearly, like an hour and a half. But I've been streaming since every day since about last Thursday, Friday. So we can do more like this if you prefer to do this than to do past papers. But either or, we can always do a bit of both. Right, completing the square. Do an easy one, first of all. So what you need to do is you need to half the middle number. So you're going to get x minus 3 squared, and then you're going to minus the number in the bracket squared. The reason why is because what we've got there then is x squared minus 6x. Okay, so that would be x, because this bracket will give you x times x, which is x squared, minus 3x is minus 6x, and then minus 3 times minus 3 is plus 9. So we want to take away the 9, so what we've got here is just these two terms. But then we need to remember that we've got the plus 1. And so what that gives us is, when we simplify it fully, minus 9 plus 1 is minus 8. So that's your answer to that one. Okay, next one, let's do a slightly harder one. Let's go with, here's one which is turning points. So we'll quickly do this one. I'm just going to do the answer to this quickly. So x plus 4 squared. 4 squared is 16. Take that away. Don't forget your plus 5. Add your 5 on. X plus 4 squared. Minus 16 add 5 is minus 11. So that's our answer to part A. How have I got that? What I've done is I half the 8. That gives me the 4 in the brackets. Then you take away the 4, the number in your bracket, squared. Then you bring down the plus 5. Okay. Oh, I've done an arrow there. That was cool. Then you bring down the plus 5. Then you simplify the minus 16, add the 5. How did I get the 9? Let me go back up. You square the number in the bracket. Okay. Then you take it away. Yeah. So you minus the number squared? Yes, that's exactly right. Okay. So whatever that number is in the bracket, okay, you square that, you take it away. It's always subtract. Okay. Right, so we've got this one, x plus 4 all squared minus 11. Now the minimum point of y equals, so we've got y equals x plus 4 squared minus 11. Now, the minimum value, basically we've got something squared here. Now, the smallest that can be is 0, because when you square anything, it's got to be either positive or 0. It can never be negative. You can never square a number and get a negative answer. So to make this the smallest it can be, minimize it, which is what we're looking for here, x needs to be minus 4, because then the bracket is 0. Square it, you get 0. Right, now once we've got that, this bracket is 0 because we plug in minus 4. Okay, and then we do 0 minus 11. So that means that y equals minus 11. Okay, and that's the smallest you can get, because like I say, if we have x being any other number, this bracket will be bigger than 0. And then if we take away 11, it's going to be bigger than minus 11. So the turning point is then minus 4 minus 11. The x coordinate is always the opposite sign, but it's this number in the bracket, just the opposite sign. Okay, and then the y coordinate is the bit you add or subtract on. Yeah, it's a GCSE question. Okay. I don't understand the stickers, but I hope they're good. Maybe you're just having fun sending stickers. That's cool. Right. Let's do a slightly harder one because there are ones where the coefficient is in front of the x squared, and we need to know how to do that as well. So, like this one, let's go with this one. Let's not make it too hard too soon, because otherwise it just gets too confusing then. You can also have ones where they've got like decimals, which are nice. And I've also seen where I did it on the paper last night that I finished, where it was a negative, and that was right at the end of the paper, but it was like a negative x squared. She had like something like minus 2x squared plus 4x plus 3 or something. So yeah, could have a question like that as well. And then your answer ends up like a minus b, and then whatever it is, x plus c all squared. It's in like a slightly different format, just because basically you end up with a negative out here. Losing my voice. Right, let's have a go at this one. So we're going to look at the first two terms, and we'll zoom this in a little bit more. We're going to look at these first two terms again. Now, because there's a number in front of the x squared, I am going to factorize that out of the first two terms. So I'm going to get 2, and I'm going to do square brackets in, we'll see why in a second, x squared plus 8x, 16 divided by 2 is 8. Close those square brackets, plus 26, because that's here. I don't know what that means, so I'm going to get rid of that comment because I don't know what it means. Right. Then what we need to do is we need to complete the square on the bit inside the brackets, okay? So we're going to get x plus 4 squared minus 4 squared is 16. Okay, close the brackets, plus 26. So I've just rewritten this bit, the x squared plus 8x, as this. I've completed the square on it, basically. Then we need to times these by the 2 again. Let me redo that, that was awful. But times these by 2 and expand the square bracket. So we're going to get 2 brackets, x plus 4 squared. 2 times minus 16 is minus 32, plus 26. So then we get, which is to simplify the end bit, 2 brackets, x plus 4, not sure what happened there, squared, minus 32, add 26 is going to be minus 6, and that's the answer. Okay, I'm going to rewrite that 4, because I don't know what happened to that. Okay, now the next bit, it says hence or otherwise. When it says hence or otherwise, it basically means use the previous answer. To find, I'm just going to make sure this is the same equation, it is the turning point. So we're going to write y is equal to 2 brackets x plus 4 squared minus 6. Now remember, we need to make the bracket 0. So x here has to be minus 4. Now if that bracket is 0, we've got 2 times 0, which is 0, minus 6. 0 minus 6 is minus 6, so y is minus 6. So our coordinate is minus 4, minus 6. Okay? Right. Okay. Next thing I am going to do, and the last thing I'm going to do today, is I'm going to do inverse proportion. But like I say, we can do these again at another point in time if they're useful. But it seems like from what people have said in the chat that they are. Sorry I haven't been able to answer everything. There's obviously a lot of questions and I've tried to answer as much as I can. Right, let's do inverse proportion. And then it's difficult as well because it's difficult when I don't know like the level of question that people want. So there's some people want me to go through the easier stuff. Some people want the harder questions. I'm trying to do a bit of both, and hopefully that's helpful. Again, like I say, right, let's have a look at inverse proportion. Not proportion ingredients questions. Here we go. Direct and inverse proportion. Let's go with this one. Okay. Right. Direct and inverse proportion. So a couple of things before we actually get into this. Direct proportion looks like this. So y equals kx. So some number times x gives me y. That's your direct proportion. Your inverse proportion is y equals k over x. Okay. So specifically asked about inverse proportion. So I'm going to go through some of those questions, or at least one of them. Here we go, inverse proportion. Let's zoom this in a little bit. C is inverse proportional to D. So we're going to write C equals K over D. Yes, I'm all right, thank you. Thank you as well about not liking the vid lock-in. Yeah, appreciate the likes and the support. But like I say, hopefully this is useful. That's the point of it. So that's the main thing. We're going to substitute these values in. So 3 equals k over 8. We're then going to multiply both sides by 8. And we're going to get 3 times 8 is 24. That's k. So then our equation is C equals 24 over D. Now, actually, inverse proportion is quite, well, probably, I think, a little bit easier than direct proportion, because essentially with inverse proportion, you always times to get the K, and then you just divide. Okay, it doesn't really matter. Well, it doesn't matter at all which way around the letters are, because with some rearranging, you can essentially swap the letters over. So you don't have to do that every time. You can just know that you can swap the letters with inverse proportion. Okay, I'm not going to be able to do probabilities tonight because I do need to get off, finish with chicken nuggets, and do some other stuff. But I will try and do some at another point in time. Direct and inverse proportion. Yeah, I can see if there's one of those. Right, going back to this question, D is 2. So we're going to substitute that in, and we're going to get C equals 24 over 2, which is 12. Okay. Right, let's have a look, see if there's one with there's direct and inverse, because I've seen questions like that before. Hopefully there's one on here. I don't know if there will be. No, I don't think there is. Right. There isn't one at the moment, so I'd have to go away and look for that, or find the paper and the question. Find the question, basically put in the chat what question number it is and on which paper, and then I can find it and then I can do that for you. That would be the quickest and probably the best way. Or I can have a look for a future time. Right, I want to do this one, inversely proportional to the cube of x. Now make sure you get these the right way around, because this means x cubed, but a common mistake could be to do cube root of x, and then obviously everything goes wrong. So just be careful about that. If it says the cube of x or square of x, that's x squared, x cubed. If it says cube root or the square root of x, then obviously that's the root. Now, what we've got here is y is inversely proportional, so y equals k over x cubed. From there, substitute the numbers in. 250 is equal to, you give them both sine and cosine rule, but not the rearranged cosine rule for the angles. So k over 0.2 cubed. Plug that into the calculator, or we could just times by 0.2 cubed straight away. Okay, times both sides by that. That will give us k is equal to 0.2 cubed times by 250 is 2, which is pretty nice. So y is equal to 2 over x cubed. And then after that, we need to substitute in x is 0.5. So we're going to do y equals 2 over 0.5 cubed. Okay. And that will give us the answer. Okay, 16. Super. Right. So you need to rearrange cosine for angles. Yes, you do. Okay. Right. What I'm going to do, because I'm going to finish the stream now. I'm going to put in a link for Maths Genie, which is where I've got a lot of these questions for, or from, sorry. And you can search, if you do Control F on your keyboard, you can search whichever topic you want. It's got the worksheets there, it's got the solutions, it's got the videos. I'm not obviously not sponsored by Maths Genie, but I just think it's a good website to use. So yeah, I'll put that in the chat for you. There you go. Where do you upload? Just type in the chat and put question, I don't know, 5, and then you could put, I presume it's IGCSE, May 2024 1H. That's all I need to know. Yeah, so just type in the chat. Right, yeah, it will take you a long time to go through all the videos, but don't need to watch all of them. You just need to watch the ones that you need to watch, you know, so just the topics that you need to work on. Right, I'll see you later. Hopefully that was useful, like I say, and we can do this again in future. All right, see you. Bye-bye, everybody. I'm gonna eat the chicken nuggets. Hopefully they're not too bad at this point. Bye-bye.